All right, everyone, we are starting with Learning Target 4-1, which is balancing chemical equations. And here are all of our sub-learning goals here, all the things you should be able to do by the end of this learning goal. So first off, fundamentally, it's important to understand the difference between reactants and products. So these here are chemical equations. This one is not very formal, but just to kind of show you an example, reactants are what you put into the reaction. So like flour, eggs, sugar, or in this case, a chemical equation, we have sodium and bromine. And then we have products, which are what get out of the reaction, like cake, or in this case, sodium bromide. So we have reactants, and then we have products. The reactants are always on the left side, products are always on the right. Then we have this thing called the law of conservation of matter, and this is described as the amount you put into an equation must equal the amount that comes out, because matter cannot be created or destroyed. Atoms can only be rearranged. So for example, let's say that I have liquid water, L for liquid, and I have 3 water molecules, and I'm going to put them through a change, which is that arrow. I'm going to put them in the freezer so that they become a solid ice, okay? I still have to have 3 water molecules. Just because they're going through a change doesn't mean I'm going to have any less water than I put in or any more. Next, we have these things called coefficients, which are the numbers that are in front of the compound. If there isn't a number in front, you're just going to assume that it's 1. This is telling us the amount. Then you have to multiply by the subscript. Remember, these little guys here are subscripts, and these help balance the equation, and we'll talk more about this soon. So when we are writing these equations, when we're writing skeleton equations, these are just kind of outlines. We have 3 steps, and our first step is to treat each part individually. Don't worry about balancing until the very end. Our second step is that most elements will be atoms. These will be single atoms by themselves. But if they are one of the 7 diatomic elements, these guys right here, they come in pairs. This only applies when they're alone, not when they are bonded in compounds. Because we know that you can have single nitrogens or single oxygens if they're bound to something else. A weird acronym we can actually use to remember these guys is HONKLBRIF. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine. HONKLBRIF. Third step to writing a skeleton equation. Most elements are solids. The liquid elements are Hg and Br2, which are mercury and bromine. The lightest nonmetals are gases. So these guys here are going to be gases, but most of our elements are solids. So our first step here is we have to convert our description, which is this here, into chemical symbols. So we have aluminum and bromine react to form aluminum bromide. So first I'm going to write my symbols. I have aluminum and bromine react to form aluminum bromide. So going back to that ionic naming, I've got my aluminum +3, my bromine, that's a -1, so naming it, it's going to be this for my formula, and this is a good start. Now go ahead and try this one on your own. Iron reacts with fluorine to form iron 3 fluoride. Go ahead, try it in your notes. Alright, now double check your equation and make sure it matches mine. Now, we have written a skeleton equation successfully, but now when we're trying to balance that chemical equation, we have to first determine the number of each element in the reactants and the products. So let's go ahead and take a look at this example here. We've got aluminum, We've got bromine and we have aluminum bromide, like we just had earlier. Then we have to do step 2, which is use coefficients, which are those numbers in front, to balance out the number of elements on each side of the reaction. So here, I've got 2 bromines, and I've got 3 bromines over here. And so having each of these coefficients be 1 would not make sense. I have to have the same number of aluminums on my reactant side as I do on my product side, and same for bromines. And right now, I have the same number of aluminum, but not bromines. So what I have to do is add coefficients. So here, I can add a 2, and I can add a 3 on this side. And this is going to give me 6 bromines here and 6 bromines here. But now I have 2 aluminums on this side. I have 2 aluminums. So I'm going to have to add a 2 here to make sure that I have 2 aluminums there. And now I have the same amount on each side. Alright, so let's try this one together. So I've got my iron and my oxygen, and then I've got my iron 3 oxide on this side. I see that I need to multiply 3 over here and 2 over here to get my oxygens to be the same. So I have 6 oxygens. I have 6 oxygens over here. Now I have 2 irons, but I have to multiply that by 2 now. So that's going to be 4 irons. Then I've got to put a 4 over here, so I also have 4 irons on my reactant side. And this is my completely balanced equation. Now go ahead and pause the video and try to balance this one on your own. So my thought process here is that I have 3 oxygens on this side. I've got 3 oxygens. So I can go ahead and multiply this guy by 3. Then if I have my oxygens all settled, then I can move on to my iron, which I now have 3 of on this side. So I have to add a 3 over here. So I have 3 irons on this side. Now, looking at my aluminums, I have 2 over here and I only have 1 over here. So I'm going to have to add a 2 to balance this out. Again, we're remembering that invisible coefficient of 1 in front of everything else. And this equation is fully balanced. We are now done with these video notes. Nice job. Go ahead and write down as many questions as you have, and we'll get a chance to answer them in class tomorrow. See ya.